Hey, what's up, guys? This one, we're going to be talking about something called logarithmic functions. These are super cool. They eventually, or not eventually, essentially exist such that we can find the inverse or use to solve exponential functions. So, to give you kind of an example, if I have x squared equals 9, before we knew, I don't know what just happened. Before we knew how to solve this, I mean, we could logically think that, hey, that could be 3, or hey, that could be -3. But before mathematicians really created what we call now the square root, we couldn't actually solve this. I mean, we could logic through it, but now that we know what the square root function is, or the cube root, or the nth root, we can use that to solve. So essentially, logarithmic functions allow us to solve exponential functions and allow us to graph inverses of exponential functions. That's why they exist. They're really not too bad. It's just going to be new, so it's going to be getting used to something that you haven't seen before. So I'm going to try to make this as easy as possible as I can for you. Just, again, anytime you guys have a question, just reach out, let me know. I'm here for you. All right. So, talked about that, blah, 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 blah. There's two forms. We can rewrite this the same way in both forms, just like how we can rewrite the square root of x as x to the 1/2. They mean exactly the same thing. So they have the same value, so to speak, if we were to evaluate them with a number. All right, so exponential form, b is the base, x is the exponent, equals n. Notice in logarithmic form, I have log of something. So log with a base of b, we call that the base. B is the base, n is the number. Notice that it's not together in exponential form, equals x. So the way that I like to look at it is, look, b and x are together in exponential form. They are not together again in logarithmic form. The base is the base. The base is the base is the base is the base. The base is always the base. So this is considered the base of the exponential form. B is considered the base of the logarithmic form as well. So the way that I say this is log base b of n. So I'm taking log of a number. And notice the line, how it's written. The b is subscript right there. The n is right on the line, just as big as the logarithm. And it equals the x. So really, all this means, with the logarithm, like if I saw log 3 equals 2, this is just saying 3 to the second equals 9. So 3 to the what power equals the thing inside. That's all that a logarithm does. Again, it's just the inverse of the exponential function. All right, so we're going to rewrite these in logarithmic form for these first examples. So notice, I have a base of b, or base of 3. So I have log base of 3 of, don't put them together again, so of 35 equals x. That's it. Base of 5, so log base 5 of a equals y. That's it. All right, notice our fancy number e, that 2.7182, that's coming back into play. So there is a special logarithm for that. If we have a log base e, you'll actually never see that written. What we see instead is something called a natural log, where we don't even have to write the base. Natural log exists because this is something that's seen in nature a lot. So it's specific to that value e. So natural log, there's an understood, we don't have to write it, base e right there, of a equals 6. So the way you'll see this written is ln of a equals 6. Natural log of a equals 6. That's how you write it in natural logs. All right. Now we're also going to go backwards, so rewrite the following logarithms in exponential form. So again, the base is the base, so 7, don't put them together again, so 7 to the 9th equals x. All right? You could find 7 to the 9th if you want to, you don't have to. So the base, a, to the other side, so 3 equals y plus 1. Everything on the inside goes. Here we have a natural log. Don't forget, the base is e, so I have e to the x equals 8 here. Right? The base is e, so the base is e. So e to the other side equals what we have on the inside of our natural log. Whoa, my paper did the wave. You see that? See that over there? It's like doing the wave. Wow. Sorry, I'm really strange. I notice weird things. That's what I get for being a math teacher. All right, so log of 7 equals 3.21. So now, notice, we have a logarithm without a base. If you see a logarithm without a base, the base that represents is a base of 10. Our counting system, base 10. So if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, then I get to 10, and it moves to the what we call tens digit. So I have base 10, so 10 to the 3.21 equals 7. I don't think that's true. No, it's definitely not true. But anyways, that's rewriting. All right. So the next part we have is determine the inverse of each function. So remember, inverse, we switch the x and y where they are, and then we resolve for y. So this is the way this works on these. So if I were to say that this is y equals a to the x, now to find the inverse, I would switch the x and y where they are. All right, so I have x equals a to the y. Now I need to get y by itself again. How we do that? I bet it's with logs. Yeah, because we're learning about logs. Yeah, totally, man. Right? So this is the way it works. The base is a. So cool. So I can say log with a base of a, so base of a, of, don't put them together again, of x equals y. Ha! Right? We got the y by itself. All we did was rewrite in logarithmic form. So I went from exponential form to logarithmic form, the same thing we've been practicing all video long. So now the y is by itself, so I'll just say f inverse of x equals log base a of x. That's it. Right? Same thing going backwards. Any base b, if I rewrite this, right, f of x is the y equals log base b of x, and I switch the x and y exactly where they are. So x equals log base b of y. Now, I'm stuck. The way I like to think about this is, I don't know what else to do. I'm stuck in log form. I'm going to do b to the x. I'm going to rewrite this in exponential form. So b to the x equals y. Hey! I got the y by itself. So f inverse of x equals b to the x. Boosh! All right, that's pretty much it. So moral of the story, and this is going to help us later on with solving as well. If you're stuck in log, go to exponential. If you're stuck in exponential, go to log. You'll kind of see how this works as well as we go through this stuff. All right, that's it for this one. Short video, short lesson. Please let me know what I can do to help you all out. All right, I'll talk to you all soon. Bye.